Later I will dive into a bit more about my job scope, but in the nutshell, it's more about designing smart cities and smart buildings in general.
You're in an energy company, right?
Yeah, energy management company.
Cool.
Correct.
And Ivy?
Hi. Yeah. Hi, everyone. I'm Ivy. I'm an environmental engineer. Currently, I'm actually furthering my studies in real estate. I previously worked in a developer, or still currently am, and my main role was actually in like planning, project management, and construction, looking more at the environmental aspects.
How about like the students? Like, what drew you to this session? Anyone? I think Matthew was gonna go.
Yeah. So I have been using the SGExam place for quite a while now, and I just saw it, and I always wanted to be an engineer or something related to that. So I guess I just decided to come.
Cool. Nice. The others?
I'm considering my future in engineering. My dad's an engineer, so I was thinking I could find out more about engineering in other sectors.
Cool.
Yeah, for me it's similar. Like I'm pretty interested in like STEM related fields, so I decided to join in on the panel to like hear more about engineering in general, because I did a research project and I was quite intrigued by chemical engineering and electrical engineering as well.
Electrical?
Yes.
Okay.
So hi, I'm Trisha. So I'm currently in Sec 2 as stated there. So currently I'm studying in School of Science and Technology, and so this year I'll be picking applied subject, something my school has. So I want to see like what other different types of paths I can try to look for, because as my dad's an engineer at Shimano, but like I feel like there's probably other sectors that I can try to look into. And I'm like very passionate about the environment, so I just want to see what other choices are there.
Cool. Nice. So the stream apparently is going live at 3:55. I am just going to go and check it out. Oh yes, we are live. So if any of you are curious, you want to share with your family and friends that you are live, like on TV or whatever, I'm putting that link in the chat, and you can share it with whoever might be keen to watch. Like, look, Ma, I'm on TV, that kind of thing. Yeah, otherwise, around 4 o'clock sharp, we'll start. Maybe I can introduce myself a little bit. My name is Louis. I run this social enterprise called Praxium. Our goal is really to help students with helping figure out what they want to do when they get older and preparing them with skills. I'm hearing myself on the live stream, so I'm going to mute my live stream. Yeah, so our goal really is to help students like yourselves figure out what you want to do next time, pick up the skill sets, find mentors, do projects, and like do that thing you want to do and let you know that it's not too early to start. Yeah, then we've been around for about 4 years plus, and we've been working with SGExams to do this career series because we do notice that many of the questions and fears that students have on SGExams seem to be around what to do next. What do I study and what do I choose? Unfortunately, in our education system, we spend a lot of time doing what it takes to get to the next step, but we don't know what the next step should be. And this is the gap that our organization is trying to fill. Yeah, so yeah, it's just a little bit more time till 4, then we'll just officially start. In the meantime, do you have any burning questions for each other before we actually go into the session? Like for Trisha and Geotica, like, I mean, something that I'm really curious about is like how you two are like females and keen to go into engineering. Trisha, particularly since you're so young.
Oh, I've been planning since P6.
Wow. Is it something like your parents talk to you about a lot?
No, it's more like I tend to study a lot, but like I really realized that if I have no aim to study towards, then it's kind of useless.
Yeah,
Because
I wish more students could hear that, because a lot of them are studying without knowing why they're doing it.
yeah, because for me, after in P6, after I got through via DSA to my school, then they were like, well, okay, what do I do now? So like a lot of people just follow like whatever their parents say and stuff, but my parents are very free for me because they feel like I should follow my own passions, which is like engineering, environmental. Then
Cool,
my parents
nice.
already said that I'm very hands-on, so I would like try to figure out what to do.
Amazing. I'm really excited to see like what you get up to next time, like, as you go further into this. So it's 4 o'clock and we're just gonna start. For whoever is here, we are really here for this panel discussion for today about engineering. This session today is co-hosted by Praxium as well as SGExams. So for introduction, if you don't happen to know about SGExams, SGExams is started on Reddit and now they're on many platforms like Telegram, Discord, and so on. And it's basically a community of students who volunteered to come together to really address things that students care about and students are concerned with. Could be about exams, could be about stress and stuff like that. So as part of that, they have partnered with Praxium, which is my organization, to look at preparing young people for the future and what they want to do as they get older. So we've been doing this work for quite a while, and we have some level of expertise that we are hoping to contribute and share to the community as well. I'll be introducing who is here for the session. So on the session here, we have our panelists. If you look at the screen, their names are there in addition to their job title or their background. So perhaps the panelists can introduce yourself again. We already did this earlier before the session started, but this time for the audience. Anyone wants to go?
Okay, I'll begin first. Hi, I'm Li Wei. I'm a research engineer doing my PhD in NUS. So I work I research in the field called communications, which is what your laptops, your handphones use to be able to get all your data transferred across the internet. So that's what I'm researching in. Yeah.
If I'm not wrong, you also studied electrical engineering, was it?
Correct. Yes, I was also electronics and computer engineering student when I was in NUS, also during my undergrad time.
Cool. Ivy, you want to go next?
Hi everyone, I'm Ivy. My background is in environmental engineering. Currently, I'm actually pursuing my master's in real estate. And prior to that, I actually worked in the planning and development in a developer. So I spent my last 3 years actually looking at construction of a new development at Paya Lebar. So yeah, nice to meet everyone.
Yeah. So if you recently went to Paya Lebar and you see all the new malls and the really cool plaza area, I think that's a lot of Ivy's work there.
Yes, I spent a lot of late nights there.
Okay, then maybe Zheng Peng, you want to share next?
Yep. Hi guys, I'm Zheng Peng. So I'm currently a system architect with a energy management company. So what we do is, if you were to look around your lights and your aircon and everything that's powered, this all need electricity. And oftentimes in Singapore, we take it for granted that our power is very stable. But basically, my work revolves around how do we create smart cities as well as smart buildings. So I think it's quite interesting that Ivy brought up Paya Lebar quarters. One of my projects, I spent quite a bit of time there as well, camping at one of the offices in the PLQ site. Yep.
Cool. And for your background, if I remember correctly, you studied material science engineering?
Correct. Yes, I studied material science and engineering in my uni. But after that, then therefore I moved into energy management. So I think that's a point that I'll touch on later, whereby engineering is quite cross-functional and there are a lot of transferable skills that you can learn, that you can apply to other domains or other factors of your life as well.
Cool, nice. So maybe I'll just, so the rest of the people on this panel for today will be our audience participants. So there's Matthew from JC1, don't need you to intro too much. Kenneth in JC as well. Joe, who's in JC, and Trisha, who's Sec 2 right now. So these are the participants who's kind of representing your student community, and they will be participating in this discussion later on. What I'll do now is I'll start our conversation by looking into this first question, which is what is engineering? I did my own research and I went to like look at the definition lah. So engineering, based on what I can tell, is the designing, building of functional, maintainable solutions to human, mechanical, societal challenges using science and technology. Like in every school assignment, we have to start with like defining our terms. So this is as far as I found. So perhaps any of our panelists, do you want to have your own interpretation or take to this?
Okay, maybe I can start. So for me, I think the most basic essence of engineering is solving problems. And it's something that's very important for humanity because a lot of times we need to do like for example, if you want to be able to eat, right? In the past, you still have to find a way to figure out how to make fire, how to process your food, how to keep your raw materials fresh, right? So these were problems, and it is through engineering that we managed to solve them to what we have today, gas stoves, electric stoves, refrigerators, and that makes life easier, which allows the rest of us, all of us to be able to do more things instead of just having to worry about, making fire, keeping things fresh. Engineers help to make your life easier so that you can focus on more things that you're more interested in as well. Yeah.
So if I just do a quick sense of that, right, based on what you share, it's a little bit about solving problems and a little bit about creating some form of an invention in a sense. Yes. Okay, how about the rest?
Yeah, I can go next. I think on top of what Li Hui has just mentioned, I think engineers play a very important role in planning what the future looks like and also ensuring that the safety of people is also being met. So a lot of the mechanical civil engineers look into how can we make sure that structures are safe, are sound for people to walk on, roads are planned properly. Even the HDB design in Singapore, it's optimized to allow wind flow through the entire city. So there's also an interesting factor that engineers play in shaping the society. Yep.
Okay, so I'll just add on here. So it seems like something about planning for future needs as well as ensuring safety as we solve problems. I was thinking about this a little bit as you were sharing. I think it's interesting because as you try to solve the problems, as an engineer, you would spend your effort thinking about how to solve it. And so perhaps it's a case where only you then have a much clearer understanding of where there might be safety breaches and where you might need to come in and design a better solution to that. Cool. How about Ivy?
Right, so I think Zheng Peng and Li, we covered most of what I wanted to say, but I think I also wanted to bring out the point that engineering is not just a science, but it's also an art. As an engineer, you not only use hard skills relating to science or technology, you actually, your role actually involves a lot of soft skills, interacting with people, finding out what their problems are, and trying to find out what's the best solution for them. So it's actually both an art and a science.
Yeah, I think it's also one of the things that people often seem to have as a stereotype that engineers are like very very science and tech, very math and science. And if I don't have soft skills, I'm not good with people, I be an engineer, which I guess is a stereotype. What can you say about that though? Like, do you see a lot of people who are that way, who are more closet in a sense?
I think definitely there are some engineers who are more soft-spoken, but they also at some point in time have to interact with others to find out whether or not the solution that they actually design suits the problems that people are facing. And so usually we don't work alone. I'm not sure about the other people on the panel, but we work as a team. So within a team of engineers, there are people who would be the front-facing ones, and then there are people who will do a lot of the back-end analysis. So it's kind of like working and complementing each other's skills in that sense.
Cool. Anything else you guys want to share before we move on to the next question? Okay, if not, what I'll move on to as part of the next question is to really ask about like specializations. Because for anyone who's choosing to study engineering, one of the first encounters would be there's so many different types, and how do I know which type do I want to do? when it came to you guys, right, what advice will you give in terms of coming up with a strategy of thinking about what specialization you want to go for?
I think for me, I specialize in electronics and computer engineering, and I think it is a lot to do with what sort of experience you had when growing up. First, you have to you decide, like, oh, I want to be an engineer. But then along the way, when you're thinking about engineering, is such a vast field that you start specializing on something. So for me, it was like doing electronics, and that's how I decided, that's what I want to specialize in. And it comes from the fact that when I was young, I started picking apart electronic items, and that built up my interest. But for those who might not have something like an idea of what to specialize in yet, I think start with something general, because there's something called like engineering science, which is the idea of understanding what engineering is about, how best to solve problems. And you can just be, you can be in that field as well. Yeah.
At this point in time, I'll just share my screen again. Here I have a list of specializations that you might encounter as you do your research. The ones I've bolded and underlined are the ones that our panelists have some experience in. Li Wei just mentioned engineering science, which, how would you describe it again?
The understanding of what engineering is about, right? Like problem solving methodologies, okay, sorry, big words. Understanding how to solve problems in engineering skills. Then like figuring out where your problems are. If you heard of something called UI UX, it's similar, but in a very more like scientific and rigid sense. Yeah.
Okay, so I don't know whether I'm right to say this, right? But I'm interpreting it as like almost like a philosophy of engineering kind of thing. Is that accurate?
Philosophy, and it has to have a quantitative part to it as well. Yeah.
Okay. Cool. Maybe you help me out, right, by looking at the list on the left and how we might start to group them. Perhaps I'll start this way. I'll pull out electrical and electronics because this is what Li Wei did, right? What are some fields you think would be most associated with your field, electrical and electronics? What's closest in concept to these two?
What jobs is?
I'm not talking about jobs, but like how close is the different specializations in conceptual proximity to these?
Probably most of them actually. I can't really see a lot because nowadays a lot of things are intertwined. The ones that I would say is not very similar would be material science, environmental, biomedical, agricultural. Yeah, the rest of them, because of the fact that they have some sort of electrical or electronic, a large focus on such things, it would be quite similar. Yeah.
Okay, so in that case, I will move this a bit closer to the center, just so that because there's so many overlaps to that. And you mentioned that these are things from quite different fields. Perhaps either Zheng Peng or Ivy, right? Would you want to draw that distinction then about what's close or what's further from your specialization?
Okay, I think in terms of material science, this very much boils down to what specialization you take in material. So a brief description of material science is materials are anything that you will use on a day-to-day basis or even in any sector. So it depends on what kind of materials you specialize in. So for example, you can use biomedical instruments, medicine, they will need material science, chemical as well. So I would say material science is the more cross-functional engineering field, whereby if you want to be able to then specialize and apply what you know in other domains, I think this is the one that is most cross-functional because you're able to pick and choose. So let's say even for electrical and electronics, there's a lot of research based upon semiconductors that will be used in the electrical electronics field. And that's where most of the material scientists or materials engineer, they go into a research field or even application. Yeah.
Nice. I mean, you can say that also particularly since you're also working in an energy electric company now, despite being from that background.
Yep, exactly.
Cool. Ivy, what about you?
So I think firstly, for environmental, it's quite a specialized engineering field. And we look at mostly about air, water, and land management. In terms of, if you go, most schools would usually group civil and environmental together in the same department. So and actually in my course, we have to do some compulsory civil modules as well. So I would group civil and environmental together. In terms of the previous specializations, I think at least from my past work experience, usually we would group mechanical and electrical engineering together because there are quite a lot of transferable skills between the mechanical and electrical engineering engineers.
Okay, I'll use my common sense to then look at mechatronics and robotics as like an intersection between electrical and mechanical as well, because those are related. I'm having trouble now with some of these other ones, right? Perhaps you guys can help me out with these. I think aeronautical and mechanical probably close. These ones. Automotive as well.
Computer and software systems will probably be similar to electrical as well.
Yeah.
Yeah. And I think chemical and biomed will be similar.
More close, yeah.
Okay. How about industrial engineering and systems engineering?
Interestingly, I would think they're close to engineering science.
Yeah, I think so. Yeah.
Okay. So in a certain way, we have some of these clusters here. I'm just going to draw the links up to some of them. I think I shouldn't draw the arrows. Just visual proximity probably good enough. Can I just get a sense, right? Another way to perhaps help students make sense of this is what do you think are the most related subjects to these areas of engineering? Is it right to say that math is very important across the board? I know Li Wei for sure say yes.
I'm going to say yes, but then again, I'm very bad at math, so I learned them along the way, and it is possible, yeah.
Okay, how about the rest? Because I foresee that in electrical, there may not be some concern about biology and stuff, whereas civil and environmental might care about geography or something.
So before today's session, I actually went to look at what are the minimum kind of requirements, and I don't think it has changed much, but I think chemical and chemistry is quite important for the bottom group. And then math, I think is a kind of a foundation that you need to kind of strengthen on.
Okay.
There's a bit of physics. I haven't used much biology, but yeah.
I imagine that biology may be most relevant for the biomedical one specifically, right? If I'm not wrong. Okay, so this some sense of like specializations, right? Perhaps like as we do this, can I perhaps invite some of you guys as the panelists, right, to show us and share with us some documents and some materials you use in your own work. You have the affordance of being able to share screen. So please go ahead. Perhaps, Li Wei, do you want to start sharing something?
Okay, hold on. Okay, let's see if I can do this. All right, so for me, I just got some slides where I'll be showing you what I know about. And let me just make sure that I have
I see a picture of you sleeping.
Yes, right. So yeah. So just everyone has similar backgrounds. We've all been students. We've all been to where you are currently or where you'll be in the future, right? And we've all slept in class, that sort of stuff. So that's the background. But this is the sort of thing that I did as an engineer in my university. So this here is what you see is a satellite, a narrow satellite about the size of like this large, okay, being assembled virtually. And I like this video because it looks nice. The other thing is also that it's a very good summary of what engineering is about. Every single piece in there has a lot of problems that engineers have solved. like you see that the red part here at the back, there's a, let me just do this, right? There's a battery, you know, there's a lot of chemistry in there, there's a lot of physics required, right? The whole structure of the satellite, there's a lot of physics simulations required as well. So when each of these parts were designed by separate engineers, and they all come together to solve one big problem, which is how do we have this thing that sends into space and records some data. Yeah.
Cool. So you actually sent it to space?
Yeah. I think it's a 6 year it is up there already. It went up in about 2014, 2013, 2014. Yeah, so it's about 6 years. Yeah. Right.
Cool, nice.
So there's that. Yeah. And of course, before all of that, you know, you don't go from nothing to this overnight, right? Along the way, you start building things like prototype. So a lot of times in engineering, you do what is called prototyping, where you have a lot of things that look very, very, you know, very, very untidy, very, very unpolished. Yeah, very rubber, very, very bad. Okay, you see, even like this one, we use like a hacksaw to cut it, and it looks very, very ugly. But the idea is that you want to test different things out. So when you're doing engineering, you have, it's like general science. You have a theory, you test it, and then if it doesn't work, you try another theory, and so on and so on. And this is what prototyping in engineering is about. You have something, and then you try it, and then whether it works or not, and then you keep iterating pieces of it, right? So yeah, and eventually, you know, this is what we use to communicate with the satellite, right? Again, a merger of multiple fields. So that's why I was saying that in engineering, nowadays, a lot of things come together. Is both civil engineering, electrical engineering, mechanical engineering, a little bit of chemical engineering, because we had to figure out like the sort of things that we need to spray on, and the materials that we use to prevent the thing from rusting, you know, in the rain and stuff like that. Yeah.
So, and you have to know that even if you didn't do chemical engineering, or you at least know how to pick it up, I guess.
Yeah. So for engineers, you start to, I mean, even though I'm in electronics, we start to have this sort of like sensing for where problems are, right? Because to be able to solve problems, you also need to figure out like where problems are. And so this is what, I mean, I didn't actually go into like, oh, what chemical is required and stuff like that. But I realized that, you know, being out in the environment is probably going to be a problem. So we actually consulted people who are better equipped or qualified to do it. Yeah. But it's something that I think on Luis's slide, you saw something called systems engineering. So this is what system engineering is about, where you have to have an overall view about what everything is, and being able to know what parts require this sort of help, what part require that sort of thing. Yeah.
Okay.
So yeah, so just some looks about like what my background was in terms of, okay, so I was in computer engineering, specifically aerospace engineering plus computer engineering, where we were doing like satellites. Yeah. So it is, yeah, quite interesting. Yeah, but day to day, like right now, I'm a PhD student, so I'm a research engineer. So a little bit of introduction of what research engineering is about is that we're on what is called cutting edge of technology or cutting edge of research, where you are trying to solve problems that no one else has solved before. Yeah. So so you're trying to solve problems that no one has solved before, and as a result, you are most of the time looking at a computer. Okay. So this is how my day-to-day office looks like. The one at the center is my table. It's really just for research. Most of the time, you're really just sitting in front of the computer, doing equations, reading up on other people's work, and see how you can transfer it to them. Yeah, and of course, if you're electronics engineering, you have some very interesting equipment as well. And there's a PowerPoint presentation, but this is really how my Chrome looks like. Really,
maybe that's just
a lot of this. Yeah, when you're a researcher, you're gonna have a lot of tabs. Yeah, and we just have meetings and where we discuss like different like updates for different types of problems that we're solving as well. Yeah, I think I can stop here first. Yeah.
Okay. Maybe Ivy, you wanna go next? have something from your own work that you can share? You're muted.
Yeah, okay, sorry, I'm just bringing out my presentation. Just making sure I'm doing it correctly. Okay. Oh no, sorry. Okay, how share screen?
Yes.
I hope you can see it. Oh no.
Yes, can see.
Okay. Yeah. So as mentioned earlier, just now, I'm Ivy, and my background is in environmental engineering, so I'm currently furthering my studies. But in terms of, before I jump into what I did in my work, I just wanted to share a bit of why I entered engineering. I think one of the things we mentioned earlier is like the environment that you grew up in and what you eventually get interested in. So I'm not sure how many of the students on the panel today have seen Bishan Park and Kallang River before it was transformed. So this is actually what the canal used to be like. I live close to this Kallang River, and it was really like just a concrete canal. But today, the same picture, same place, but it's now a very nicely transformed river. That is a lot of engineering went in there by courtesy of the PUB, obviously. But I think this was one of the transformation that I witnessed for myself that kind of inspired me to join the engineering field. Yeah, so as mentioned earlier just now, in environmental engineering, we mainly looked at 4 areas of studies. Mainly one would be air. So at the bottom right, you see what Singapore is like when there was forest fires in Indonesia causing air pollution. We also look at waste management. So like the recycling bins on the top left, where you see, we look at how do we encourage people to reduce waste, to recycle materials. And then on the bottom left, you see a flow chart of water treatment, which really was the main focus of environmental engineering studies when I was in NUS. And then on the top right-hand corner is basically what I am currently mainly doing, looking at green buildings. How do we design buildings such that they would reduce environmental impact? Yeah, so in terms of
I
my
assume
journey,
it's not as easy as just putting plants in the building, right? I assume.
Of course. Yeah, it not only plants, but that is something that I myself is passionate about. So I always look at how do I actually make our buildings and our developments greener. There are not only environmental impacts, positive impacts, but also like wellness for people generally. Yeah. So I actually started off as an intern working on GEM. So anyone living in Jurong East would may know that Jurong East used to be like bare land. There was only a skating ring maybe, and then now it has transformed with hospitals, malls, and things like that. So I was an intern. I actually did a lot of tenant engagement and encouraging them to look at environmentally sustainable products in their fit outs. Yeah. And then when I started working in my current company, I looked at using timber for construction, which is actually very rare in Singapore. There are a few small projects in Singapore that uses timber as the structural material, but in Singapore, most buildings are still built with concrete, steel, the more conventional type of materials. So I've never actually studied about timber when I was in school. Jumping into timber as my first job was a bit like challenging. I had to learn a lot of things from scratch. But thankfully, I managed to go on a few site visits with my company. So that's actually me in a not very cool outfit, but we had to, we basically studied how Australia actually used timber in construction. So all the beams and columns are all using timber.
You look quite
So
cute, lah.
There are more pictures of me in hard hat, so you can look up later. So yeah, so actually, through learning about using timber in design, it can actually be a very aesthetic material, but also it doesn't compromise safety for the users. It's actually how the timber is treated would actually affect the structural properties of it. Yeah, so I learned a lot through that first stint I did. So this was in Japan with my colleagues, learning about how Japan takes a different timber material. So they use cedar trees instead of the other types of trees in Australia. Yeah, and then jumping from there to Paya Lebar Quarter. So this is Paya Lebar now, but in the past it used to be just empty ground. I'll show you a video actually of one of the first initiative of what I did as an environmental engineer there. So basically in this actually shows what Paya Lebar used to be like. It was empty land, perfect for picnic. Everyone loves picnic under the big trees. But as a result of our development, there were careful considerations on what we do with the trees. So my first job was actually looking at how we can, if you can see here, there's a few banyan trees there. How can we actually develop without compromising, or rather by saving some of these trees that used to originally be on site? The trees were really, really old, and we had someone to come and look at it. And instead of replanting these trees because they were too big and old to replant, we actually propagated some of these saplings from these trees. And now back in our development, we have some of the saplings. So I'll let the video tell you more about our journey in that. And this is one of my proudest initiatives actually at Paya Lebar.
Are you playing the video right now?
Yeah.
You'll need to share screen to the video. You need to press share screen again, show the video, and then click share computer audio. It's an option before you share.
Okay. Right. Okay. Sorry. I'll try and again. Share computer sound. Right.
Right after the video, Zheng Peng will share.
Yep.
This is the story of a banyan tree that used to sit on the site. As part of our conservation efforts, 80 saplings were taken from the tree and put up for adoption by the PLQ team members. 2 years on, they are lush and thriving and ready to come back to a new yet familiar home. This exciting journey home is part of a Scandinavian tradition, the lifting of a tree to the top, marking the structural completion of a building. This is of special significance to us, as it was introduced to land lease by our founder Dick Dusseldorp, and has since been part of our story. Today, we celebrate and mark a new beginning, the topping out of PLQ. Rediscover.
Yeah, so that was kind of the end of my sharing. But basically, being an engineer on the project made me quite proud. So every time I go back, I'll actually see something tangible that I've created.
Nice. Thank you very much for that sharing. Nice. Thank you very much. Okay, Zheng Peng, you want to go next?
Yep. Hang on, let me share my screen. Can you guys see?
Yeah, can.
Cool. Okay, so I think I just want to start with a common theme of why we choose engineering in the first place. So I think Li Wei and Ivy has both shared. So I think for me, the common theme is about sustainability. How can we make an impact on the world in a positive manner? And how can we drive green buildings, how do we ensure that the earth is still livable in the future? And that is why initially I took up materials engineering, because I was very interested in the solar panel field of how can we create materials such that solar energy or any form of renewables, it's an efficient source of energy. And I'm sure that the students on the panel, you guys also know when we talk about a lot of the fossil fuel, it's number one, quite polluting. Number two, it's not very sustainable. So that was my main thing. So on the screen, you can see this is what materials engineers do, is that we look at things at the atomic level, we add stuff and we add materials into other materials to enhance the features or the aspect of the material that we want to see. And then thereafter we can create. So things such as creating stronger concrete, stronger materials for building is something that we do. Creating more energy efficient solar panels is also a strong form of research. And then lastly, there is something that's getting more and more popular, which is looking at how can we create better medicines. When medicine goes into a body, how can we affect the influence on yourself and how can we enhance the healing of it? And even making prosthetic arms, prosthetic skin is also an area of research in materials engineering. So that's what I did in the undergraduate in my uni days. But then things took a big turn when I went into my full-time job. So currently, what I'm doing now is as a system architect. So basically what I do is to solve problems for clients. So they have an energy management problem, either that or they might have a power problem. So in Singapore, we typically take this for granted. Our power is one of the most stable in the world. But in places such as India, places such as the not so developed countries, they face a lot of power shortage, number one. Number two, their buildings are very inefficient. They waste a lot of energy. So that's where I come in to design more efficient building, greener buildings, as well as ensure that power is reliable. So my end of engineering, as contrast to Li Wei, is not really about creation and research, but mine is more about application. How can I glance upon the portfolio that scientists and researchers has created, and how can I apply them in a cost-effective manner, but at the same time helping the clients and the customer to save energy. So this is one of the projects that we've worked on. I think the Singaporean students will find this familiar. So Jubel Airport and the entire Changi Airport that we have, it's powered fully by my company. So imagine if Changi Airport were to run off electricity one day, like a short circuit in your house. So at home, it's very easy for us. When the lights goes off, your parents will probably take the chair, go up to the circuit breaker and then flip the switch back on. But imagine for a terminal such as Changi Airport, they have so many electrical breakers and meters. How do they effectively keep energy up and running? So we provide the software and solutions for them to identify, as well as the hardware. So my career path has been quite interesting so far. So I think just wanted to point out that within the 2 years, and I have embarked on the 4th role in my 2 years working full time. My rotation consists of mechanical engineering, so looking at how we design efficient cooling. So in your house, you have aircon, but in larger buildings, we have what we call a cooling system or schematic. That's where the mechanical engineering comes in. I spent another 8 months on electrical engineering, looking at how can we, like I mentioned, how can we keep power on, and what if power goes off, what do we do? And then the last rotation that I spend a lot of time in is in system engineering. So designing effective system, looking at data flow, how can we ensure that communication is as fast as we need. So when we talk about digital transformation, that piece is a very critical portion of making systems work. So when it comes to a green building, I take care of all of the energy management point of view. So I apply this kind of theory and apply equipment from third parties or even from my company to fit into a perfect solution, or rather not perfect, but the best solution for the customer. So I just want to share some of the site survey pictures that I've took previously. So my role as a pre-sales engineer takes me to places that typically nobody can access. So I've been to Changi Airport, the back end of things. And trust me, you wouldn't want to walk at Changi Airport. It's 10 plus kilometers every single time. Every time I go for a site survey, it's clocking at least 20,000 steps. So these are an extension of the breakers that you see at home. So the electrical rating that we see at home is much lesser, but this is the bigger version for bigger equipments. And this is also similar to your aircon at home, but it's also much bigger. So this fits the entire building or the entire data center. So we are now very used to being digital. We have our phones, we have Zoom right now, and we have our computers, and we are constantly on the internet. But what keeps the internet up is data centers. And what I tend to spend most of my time on is also visiting data centers and helping them to design a lot of the solutions that they have in place. Yeah, so overall, this is just a sharing. I think the main takeaway here is that my advice would be to find something that you're passionate about. I think the specialization comes as a means to an end. So it's for you to want to solve a problem. That's why you go and pick up a certain specialization. So the specialization isn't so important. The why behind the specialization is more important. So I think it's, again, spending some time thinking about what kind of problems you want to solve and what kind of things that you are passionate about. So this is a quick overview of what I do on a day-to-day basis. So as I mentioned, this is I'm transiting to my 4th role already. So it's a different engineering role again. It's more on IT. So fun times as an engineer. Yep.
Nice, thanks for sharing. So now it's about the time where we want to ask some of the student participants here to maybe ask some questions that you have to our panelists. Does anyone have something you want to ask? Yeah, Jyoti.
Hi. So I wanted to ask if it's very common for people to switch between engineering disciplines, say perhaps halfway through studying a certain degree, you feel that a certain discipline might not be suited to your liking and you would like to try something else out. Is it very common, or do most people just stick to this discipline throughout their entire careers?
Okay, I start first then. For me, I think I've stuck with the same field for a very long time. I think for most people, because the thing is you need to learn a lot to get to do your engineering job. So it's very difficult for you to just totally change away from what you were doing previously. But what you'll notice is that you expand from where you are. So for me, I'm an electrical engineer. I actually learned a little bit of mechanical engineering, a lot of software engineering, a lot of cybersecurity stuff as well. So that's where you start changing a little bit. And eventually, if you've learned enough or if you've expanded enough, you should be able to switch to another field. But most people, they stay at the same field for generally the rest of their career unless they decide to change to a totally new career.
Yeah, I think adding on to that note, I think specialization that we show earlier is also very broad. So let's say doing in just chemical engineering or just biomedical engineering, there are a lot of different fields within it, and there are a lot more, even more specialization within that specialization. So I think it's also about finding that niche that you can play in and you can contribute in. I think that's also something that you should bear in mind. So I think it's about understanding what you want to do and then getting that skill set to fulfill and solve that problem as well. Yeah.
Yeah, and I think I'm not sure about Li Wei and Zheng Peng, but in my university time, the first year is mainly foundation. So you actually get exposure to all engineering. Like I had to take a module on electrical engineering and I did really badly. And so I decided that was not my cup of tea. But I think it's you get a chance to explore the different engineering disciplines in the first year. And then, but at that point in time, you would have already chosen, let's say, for example, for me, it was environmental engineering as my specialization. But there is still a chance that in the next year, you get a chance to apply to switch to another one, another specialization that you prefer. And also, as Zheng Peng mentioned, within each specialization, there's a sub-specialization. So like for me, it could be either air pollution or water management, etc. So there's a chance to switch over. Yeah.
From a career planning viewpoint, right, this is something we call a T-shaped skill set. So generally, you would have a broad base where you have a few areas that you're familiar with or have some experience with, and then you would specialize into one area or like deepen a few skill sets. So in a sense, like when you ask the question of, is it common to switch? Yes and no, it depends on the person, but from a career advice standpoint, it's a good idea to pick up multiple. It will help. So thanks for that question. It was a good question.
Maybe I want to add in a little bit. Yeah, so shifting between different engineering courses, what you also notice is that you have the basic skills that you learn, like Ivy was saying, the first year of engineering school. So these things actually, so for engineering, you basically have the same set of basic skills, like the mathematical skills, how you analyze things. And what goes on after that is understanding what is available to you, right? It's like, I want to build a table, and then you look at, oh, these are the tools I have, how do I put them into a table? And that's what engineering is about. You learn how to put things together, and then for different specializations, you just understand what sort of materials are available to you. Yeah.
Cool. How about the rest? Any questions from you guys?
How's the work-life balance being an engineer in your sector?
Work-life balance.
I think the topic of work-life balance typically comes down to the individual. I think as an engineer, it's up to your preference on what kind of. So it always comes back down to what problems you want to solve and how much time and resources you want to invest. I would say that there's no clear-cut answer in which career will demand more of your time. It again depends on your company, your sector, your industry. So I wouldn't say that engineering itself is a very labor intensive or rather hour-long kind of job. But each of the specialization will bring each of the flavors to it. So for myself, a lot of my time currently I spend with customers and writing proposals and putting together and designing solutions. So again, I also spend a lot of time sitting in front of the computer itself. So then my work becomes more flexible. Yeah, if I want to work at night, I can do it. But let's say if you are just a mechanic, if you are a mechanical engineer who designs buildings, I don't think it's very easy for you to bring your drawings back home and start sketching at home. So again, it comes back down to the limitations of that specific job and that specific industry. Yeah. Not sure whether the rest of the panelists will agree, but yeah.
So general input, regardless of industry, do take note that the companies you enter make all the difference also. So some companies are very balanced. Stereotypically, European companies tend to have a better work-life balance. Asian companies tend to have worse, but that's again a stereotype. So it depends on the context that you are looking at. Do the rest want to add on to that?
Okay, for me, I think, okay, one, there's the personal choice where actually, if you want to have work-life balance, you can have work-life balance. Just when the time hits 6 o'clock, just go home. Nobody will stop you. Your boss might be unhappy, but generally it's okay. Yeah. For most people, when they start working longer hours, it's more because of personal passion. That said, when it comes to engineering, a lot of times things that are more applied, meaning where it's more hands-on, when you like do things like drawing by hand, you tend to spend more time on it because once you get started on it, it's very difficult for you to stop and then start again the next day. So for me, as an electrical and electronics engineer, when I do things that are hands-on, I tend to just finish it before I go home, and that means that I have to stay longer sometimes. Yeah, and so the idea is that if there are things that are more hands-on, it's more likely that you'll need to be able to sacrifice some of your personal time as well.
Ivy, any inputs?
Yeah, so I think like Li Wei mentioned, work-life balance is also your own decision, but then it depends on the work culture in the company. I think that's one of the key thing, and sometimes it's even down to the level of your direct manager, because different managers, even in the same work culture, could have different like expectations of you in terms of work-life balance. That said, it also depends on your role as an engineer, what you do. If you're more on the strategic level, so you're planning, strategizing for 5 years, 3 years, then you get a more chance of flexibility. But like in the last 3 years when I was working on a project, because the project has milestones or deadlines, there are only certain things you can do at night. Like my colleagues had to build a bridge at 3 a.m. There's no such thing as work-life balance because you had to wait for like the roads to be clear. So I think in the construction industry, sometimes it really depends on your project cycle. It's a cycle. Sometimes it's more stressful, less work-life balance. But in Christmas time, most people are away. So yeah, it's a balance that you also decide on your own.
If I'm not wrong, some companies also, depending on company culture and policy, would make up for days where you overwork. So you might have off in lieu and stuff like that. From my own perspective, because coming from Praxium, we look at people from different industries. So from my survey across multiple industries, engineers' work-life balance is relatively average. There are certain fields where overtime and long hours are much more regular, or across the board, engineering is relatively even. I also want to have another perspective, which is this question about work-life balance. I think it's exactly why it's important to enjoy and feel some passion and interest in what you do, because in the event you have to work more, at least you work more for something you want to work more on. So that's kind of ideal lah. The other thing I want to show also is another perspective from a career planning perspective. Talent always comes with more responsibility. So if you are good at what you do, if you are skilled, intelligent, resourceful, you will get more work to do. So that's one challenge. So sometimes people may get a lot of work and stuff like that. It tends to be the case because they do good work. And you have to expect that when you do good work, more work gets piled on to you. My first learning for that is during army, which I think everyone might be able to resonate with that also. We have time for just one more question. Does anyone want to have a go?
How often do you get holidays?
I think same as everybody else. Yeah, but I think as what Ivy has mentioned, if you're working in the industry whereby there are deadlines, then you have to meet the deadlines. But I think we also recognize that, especially in Singapore, the employment laws are quite fair. So even if you were to be working overtime, typically the company will compensate you based upon the hours that you have. So it's about ebb and flow. Sometimes you have very high intensity period, but after that you get a chance to deload a little bit and just wait for the next project cycle to come about. Yeah. And again, holiday is very company dependent. Yeah.
Yeah, employment rules require you to be on holiday during like public holidays, and of course you also have leave as well. And here's one thing, because I'm a research engineer, meaning I work under a university as a researcher. I'm also doing my PhD. So one good thing, I guess, about that is that as a research engineer, you're more like a student at the university. So you are more flexible in terms of the leave that you take. For example, I have 21 days of leave. If you are talking about work-life balance as well as how just being able to take a rest for an extended period postgraduate education, postgraduate or research engineering might be quite interesting for you as well.
Okay, I will move on, right? So I wanted to end it off just so that we can answer some of the questions that came from people who sent them in. So I think one interesting question that people are asking that's pretty relevant is like the current landscape. So what is like the trends? How is the market doing? What's the industry like? Perhaps you guys can share a little bit.
Yeah, okay, I guess the talk of the town is always about, currently it's about software, it's about a lot of the tech place boom. But I think again, we just want to be mindful here to note that these are typically just trends based on market global trends that is happening in the world. Typically, if you are just banking on a trend and you don't like whatever you're studying, the trend might fade. As with any fashion trends, as with any trends that are currently in the market. So I think it's also important to note this fact. But again, we also need to recognize that software and technology development has been one of the key topics, especially when we talk about having a more digital space, having a more globalized economy. This is, again, the trends that the market is moving in. But again, who knows, 10 years later, and especially with how fast tech is moving, 5 years might be the life cycle of a certain trend itself. So it's better to prepare yourself with a skill set that is transferable and you're able to adapt to any changes that comes with the market.
Yeah, also aware that, yeah, you go ahead.
Yeah, agree on that. So the biggest thing that's going right now, yes, is software. Specifically right now, there's a lot of things about AI, virtual reality, biomedical engineering. Actually, there's a lot of advances in there as well, right? So, but the thing is, these things change, not even 10 years, like 2, maybe even 5 years. By the time you are in the workforce, it will be something totally different. And then these things cannot be predicted. So as Simpeng was saying, something that's transferable is very important. And that means that being able to understand or learn something new. Like learning to learn is this phrase that's commonly thrown around, which is basically allowing you to just know how to Google search one thing. The other thing is knowing how to search well when you're faced with a problem, how do you navigate around it? And interestingly, for engineers, this is something we're very good at. Yeah.
Essentially problem solving, like what you're saying, that no matter like even if you do choose to go software, that you can still solve problems even if it's not software problems eventually. Okay, Ivy, anything to add? If not, we'll start to close off.
Yeah, I think just final thing on trends. I think as Luis mentioned, you know, software is not just for solving software problems, but like trends like climate change, for example, are things that can be solved with like across the different types of engineering, where we come out with different solutions for climate change issues. And then also, as we are all experiencing now, you know, pandemic, as a pandemic, how can we better future-proof or prepare ourselves for that? And then engineers do actually play a role in whether it's it biomedical field or chemical in the different specializations.
Yeah. Actually, to add to that, that means one thing that is very, what was I saying? Never
mind. Okay.
I lost my train of thought for a moment.
Sure. Yeah, maybe engineer a solution to that. I'll just end off with a few closing notes. I think one of the things that, as I learned about engineering from a like layman's perspective, I gained a lot more appreciation for how actually engineering is everywhere around us. So earlier today, I risked my life to go out of my house to go and film this video to show you like engineering in our everyday life. So this is like a traffic junction where like it's normal lah. Like you guys will always walk at a traffic junction like this. But if you have, I don't know if you've ever noticed these black color lines on the floor. And what these black color lines are essentially traffic signaling devices. They sense whether a car or a vehicle is over it. And you see these lines connect out onto the edge of the road, and they actually connect up to these boxes here. And these boxes are essentially the thing that determines your traffic light, whether it's just green or red. And also, it's because of these sensors. It's not just based on timing. In addition to that, near my house, there's a construction on MRT, and there's a lot of vibrations and noise ongoing. This is something you might encounter because Singapore has a lot of construction. And one thing I noticed was this monitoring device here, which then got hooked up here. There's another device, and then there's a solar panel here. So things like that, I believe, are what engineers work on a regular basis to create these things and to get some sensing. I took some photos as I was risking my life as well. So from an automotive perspective, you might see like a motorbike and all the different parts of it and how it works together. How each part is even manufactured is something engineers need to be thinking about. And here is from a more environmental perspective. If you didn't know, every single tree that's planted in Singapore exists on a document somewhere on the plan of a company or the government. Every plant is planted with a specific thing in mind, and a certain distance apart and how to maintain them and stuff. This is another thing along where I was looking at like the construction near my house. So you will see things like that around, and you can actually see engineering everywhere. Just to close off, I'm going to share with you a perspective that really comes from our expertise in career planning and career frameworks. So if you look at this, when we look at any industry of work, this is the kind of mindset we have. If you are in engineering, you'll be engineer. If you're healthcare, you'll be doctor or nurse, urban planning, architect, hospitality, hotelier, media, filmmaker, arts actor or something. But the interesting thing is that you can actually look at them in a different context because this is just the default job you think of. Let's say the domain of knowledge we have is in engineering. In this engineering field, right, we essentially are looking a lot into innovation, R&D, manufacturing. And you find that Liwei, for example, is deeply in that field. They might be working in factory lines, doing production work, doing 3D drawings and like efficient production methods. But if you work in a healthcare sector, these bolded ones are probably some specializations you might be looking at as you work in the medical field. And the ones not bolded are probably the kind of work that you're working on. How do you make sure that whatever medicine that you're making, you have like the tons of like chemical ingredients required and then filtered in to be able to make the pills you have, and the prosthetics, which Zheng Peng mentioned about the materials you might use for that. And even in urban planning, you have so many other fields. And the reason this is so long is because the mission of planning the city is actually really complex, and you need so many fields of things to consider and create effectively. In hospitality, even if you look at hotels and all that, in case you didn't know, every room has electrical components inside, has a plan, and everything needs to be carefully managed. So some of these domains and aspects are relevant. And this comes from people from the hospitality industry that I speak to. They do have engineers in their company. Just imagine MBS. You have to have some engineers employed to run that whole place. Even in the media sector, you might have AR, VR, and all the editing software you use, the cameras and media equipment you use. Engineers may be operating in these fields. And for, like, say, the arts, in case you ever gone for like plays and theater shows, the set design that they have is often very complex. How do you get like just this plain wooden floor to show like all these complicated stuff? Mechatronics and all that might be involved as well. And this is just an example that I wanted to share with you about how engineering can actually cross into many different fields. That's about what we have for today. I am going to tell you what we are going to do next. After this session, all the sketches and drawings and data we collected, we will be sharing them on an article in collaboration with SGExams, so that anyone who may not have joined us for the live stream gets to get the insights and knowledge that we've shared today also. We will be trying to consolidate and analyze whatever has been shared for easy consumption. And in addition, we also would like to invite you guys to fill in a feedback, particularly for those watching on live stream. So for those of you watching on live stream, you can see on the left here, the QR code for our feedback form. In addition, if you're interested to learn more about different careers and get advice about how you can prepare yourself for your future, there's a Telegram group you can consider joining. We do have certain tips and advice will come up regularly, as well as events and panels like this we will organize on our own sometimes. If you also want, you can follow us on Instagram. You will see a little bit about the work we do and opportunities that we might offer, which include programs we might run, or internship opportunities and events. Yeah, so there's this feedback form, please fill it in. That will help us as we organize the next session. And just to promote a little bit, tomorrow evening, Praxium is actually running an event called Learning Day. We actually create this session so that anyone in particular can come in and share and teach something. So if you found like Li Wei sharing interesting, for example, Li Wei is quite a regular participant at Learning Day, and he would share some of the things that he does in his engineering work as just a thing for average people to learn about. But in addition to these events, many other people from different industries also come in to teach about what they do and the things that they know as well. So feel free to join this. You can look for us on Facebook, primarily on Facebook, or you can like take note of the Zoom ID and password and join us there as well. So those are just some of the things that we have moving forward. Next up, after this particular panel, we will be working with the SGExams team to develop more panels on different industries. The upcoming ones may be around the field of finance, software, and if I'm not wrong, the arts or media. So these are some of the ones that will be coming up as well. So otherwise, we overran by a slight bit. My sensing is that everyone's feedback form will say that it's too short. So I thank you very much nonetheless for spending that time with us and appreciate it very much. Hope it was something useful for you. Do throw us any questions or try to connect with us if you have any feedback or things you want to say. I also want to thank all our panelists as well as all the guests that have joined us for today. Li Wei, Ivy, Seng Peng, Matthew, Kenneth, Jyoti, and Tricia. Thank you all for joining us, as well as the SGExams team, Kathleen particularly, for helping set up the live stream. Otherwise, have a good day. Yeah, it's approaching dinner time, so go and enjoy the rest of your day. Okay, thank you. Thanks, guys.
Thank you.